This video is on section 5.7, which is synthetic division. It's a continuation of the techniques in section 5.6. So, like we learned last time, if you're dividing a polynomial, like 2x squared by something like this, you can use long division, where you set it up with the box like you would have done with long division with numbers, and then you go through and work that out. But there is an easier way when you're dividing by a binomial that has the form x minus c. So really that's any binomial where the leading term is an x with a coefficient of 1. If I had x plus 2, I could think of that as x minus negative 2. X minus 2 is x minus 2. So we'll go through a couple examples with those. So the really important thing to look at is that your highest term is an x, not a 2x, not an x squared, or anything else like that. So here's an example. So I have this trinomial here, and I want to divide by x minus 2. So this is of the form x minus c, where c is 2. So I'm going to take this 2, put it in a box, and then I'm going to take the coefficient of each term. So here we are going to put a 1, a minus 10, and a 16. Then I'm going to move the 1 down, and I'm going to multiply the 2 times the 1. So that 2 times 1 is 2. I'm putting it up here. Then I'm just going to add. So negative 10 plus 2 is negative 8. Then I'm multiplying again. Anything that ends up down here gets multiplied until you get to the end. So we have 2 times negative 8, which is negative 16. And then when I add those together, I get 0. So now what I do is I found the coefficients of my new polynomial. And the new polynomial is going to have 1 power lower than the original. So the 1 is going to go to an x. And then negative 8 is just going to be a number. And having a 0 here in this last space means that you have no remainder. So that is a fast and easy way of finding out the factors of a polynomial, or dividing a polynomial, that is. So I'm going to do another example. X cubed minus 5x squared plus 7 over x minus 5. So I have my x minus 5 here, so the 5 is going to go here, and then I'm going to take the coefficients. So the x cubed is a 1, the x squared had a coefficient of negative 5, and then there's no x to the 1 term here. So I have to put a space for it, so I'm just giving it a 0. And then there will be a 7. So this was the x cubed minus 5x squared. This is like a plus 0x, and this is a plus 7. Bring down the 1, and I'm going to multiply it by 5, which will give me a 5 up here. Negative 5 plus 5 is 0. Then I'm going to multiply that again. 5 times 0 is 0. And then when I add 0 plus 0, it's also 0. Okay, so now I have 5 times 0 again, and I'm going to bring down the 7. So I don't have a 0 here, so that means there will be a remainder. So now I'm going to go ahead, and since the first power here was an x cubed, my first term will be an x squared, and that's going to go with the 1. And then I would have 0x plus 0. And then the 7 is going to be over x minus 5. So my final answer, I don't need all these 0 x's here, is going to be x squared plus 7 over x minus 5. Here's another example. If I wrote this one as a fraction, a lot of the time people would be very tempted to just divide the x squared by x and the 16 by 4 and think that that would be x plus 4. That is not true, because you have to be able to divide both terms on top by whatever you have on the bottom. So we're going to do this one with synthetic division. Since this is a plus 4 here, I'm going to take a negative 4 for synthetic division, because this is like x minus minus 4, which is a little bit strange, but just remember that it's the opposite sign. Then my x squared had a coefficient of 1, so I have x squared. There wasn't an x to the 1 term, so I'm putting a 0 for it. And then I'm going to put the 16 right there. So now the 1 is carried down. Negative 4 times 1 is negative 4. If I add these two together, I'm getting negative 4 again. So then I have negative 4 times negative 4, which is positive 16. So now I'm going to add in my x's. So the highest power here was 2. So the highest power in the answer should be 1. So this 1 should go to an x. Minus 4 will just be a constant. And 32 is a remainder. And it's going to be over x plus 4. So you can see that this answer is very different from what you would have expected if you tried to just divide it directly. So the final example it is a problem that has fractions. So I have 2x cubed minus 4x squared plus 3x plus 1. And then I'm going to divide by x plus 1/2. That means that in my little box up here, I'm going to have a negative 1/2 because it was positive over there. Then I'm going to bring down that 2 minus 4, 3, 1. This time I don't have to add any zeros because every possible x power is accounted for. Now the 2 is going to come down, and then negative 1/2 times 2 is negative 1. That's going to be negative 1 there. And when I add those two together, that gives me negative 5. Now negative 5 times negative 1/2 is going to be positive 5/2. So I have 5/2 here. So now I need to add 3 plus 5/2, which, if I multiply 3 by 2 over 2, is 6/2 plus 5/2, so 11/2. Now, I take this and multiply by the negative 1/2, so I have negative 1/2 times 11/2, which is negative 11/4. Okay, so I have 1 minus 11/4, or 1 plus minus 11/4. I can turn that 1 into 4/4. Subtract the 11/4. That's going to leave me with negative 7/4. So now when I add in the x's, my highest power of x has to be x squared because I started with an x cubed. So I'm going to have 2x squared minus 5x plus 11/2. And then I have negative 7/4 over x plus 1/2. Now that is not really the form we want that in because we don't want to have fractions inside of fractions. So what I'm going to do is, looking at the fraction in the numerator and this fraction in the denominator, I'm going to figure out what the least common denominator is. So in that case, it's going to be 4 because 2 goes into 4. And so I'm going to multiply both top and bottom by 4. So that is going to be, it's going to cancel here. So that would be negative 7 on top. And then 4x, and 4 times 1/2 is 2. So in my final answer, I'm going to have, make that about the same size, 2x squared minus 5x plus 11/2 minus 7/4x plus 2. I want to do this one a little bit bigger over here. So if I have this, the least common denominator of 4 and 2 is 2. Is 4. So I'm multiplying this one, this fraction on top by 4, fraction on bottom by 4. And so 4 times x is 4x. 4 times 1/2, 2. And 4 over here is going to cancel and leave negative 7. So that's where that remainder came from. And those are the that's the process for synthetic division. And that's the end of section 5.7.